But what we recently implemented is that the system also suggests to the user possible ways for continuing the current search. So for that, the system analyzed the current search result and the way of getting there. And then the system at the bottom of the result list indicates the availability of suggestions for continuing the current search. And they are presented in a ranked list when the user pushes on this button. And the user can execute one or more suggestions from this ranked list. And we evaluated this feature with 24 computer science students. It was presented by Sasha Krivel at ECIR 2010, and he got the Best Paper Award for this. And the major findings of this study were where we had 12 students doing searches with this feature and 12 students having the same system but without the suggestion feature. And we found out that the supported users are more satisfied with the search result. They find more relevant documents, and they also make more use of Daffodil's advanced search tools. On the other hand, the unsupported users, they mainly focus on reformulating the initial query, so they did not use any of the sophisticated tools that were provided in Daffodil, although they were initially given the same introduction as the supported users. So we can see that, in fact, it's possible to help the user getting to better results by providing a system with the appropriate features and then guiding the user through the search. So to summarize this discussion about context, I'd like to use this figure published by Zarachevich and Kovi some years ago. He did this for the area of digital libraries, but I think it's also applicable to IR systems in general. So he has a stratified model of evaluation context, starting with the content level, where we are only regarding what's the content of the system on which the search engine runs. Then we have the processing level, so these are our IR models and methods. Then we have the engineering level, how are these methods actually implemented. Then we have the interface, what kind of interface does the system provide to the user. Then we have the individual, regarding the individual, so to what extent does the system help the individual in solving her or his task. Then we have the institutional level, for example, to what extent does a university library help to support the university as a whole. And finally, we have the social library, so for example, looking at public libraries, are public libraries useful for society as a whole. And now we can perform evaluations at all these levels. Here we have the more system-centered evaluations, and here the more user-centered evaluations. And mainstream research mainly focuses on the processing level, so comparing different models and methods and ignoring all the context that's above. Since some years we also have user studies, and the user studies, they focus mainly on the individual level, so looking at task success rates, for example, and there are also some studies looking at the interface, how can we improve the interface of an IR system. So looking at this picture, we can see that, well, we should no longer restrict to this level. We should try in the long run to cover the whole area of the context in order to get a better picture of what's going on and to develop systems that are really helpful for individuals, institutions, or society. In the last part of my talk, I'll try to point out some directions, some more general directions, and some want to pronounce also some more fundamental critics. So starting again with an analogy, well, if civil engineering were like information retrieval, well, when in former times when people wanted to cross a river, they just laid a trunk of a tree, or maybe more than one, across the river, and they reached the goal. And well, if the trunk broke, then next time they would use a thicker trunk in order to be able to cross the river or whatever. But here we can already make the observation, well, we hardly know what a thicker trunk would mean in information retrieval. If method A does not work well, what's a thicker method? Well, we do not know, but in contrast, in civil engineering, people were able to specify, well, they computed relationships between the thickness of a trunk, the length of a trunk, or the type of wood. And so by means of experience and doing these computations, they were able to build more solid bridges, like, since we are in Italy, this one should not miss. It's only 50 kilometers from here, as you surely know. And so over the years, more and more findings and also theoretic models were developed. So especially during recent years, during the last 50 years, finite element methods that are able to predict the solidity of such a construction. Well, at least most of the time, this works successfully. And so civil engineering now has a solid basis. So given a new challenge, then engineering is able, without doing experiments beforehand, just to predict the size and the layout of the bridge, and it will be solid for centuries. Now compare this to information retrieval. Given a completely new test collection, do we really know which retrieval method will work well? So for that, let's look at the experimental variables of the more system-oriented approach. So we have here again the same picture. So we have the controlled variables. We have the documents, the topics, and the relevance assessments. These are given. And then the independent variables, which are usually studied in most of the experiments, are the representation methods for documents and queries, and the matching method, and the evaluation procedure. And then finally, the dependent variable is the evaluation result. And the focus currently is on modifying the independent variables in order to get better evaluation results. But what about the controlled variables? What if someone comes up with a different document collection, or uses different types of topics, or if the concept of relevance is defined in a different way? How are results affected by these components? Well, we don't know. So when we look at the controlled variables, their characteristics, then the great challenge for our field is, how is IR quality affected by characteristics of documents and topics? For example, documents may vary in length, collection size, vocabulary size, domain, genre, structure, and so on. Topics, for example, might vary also in length, linguistic structure, application domain, user expertise, and so on. And similar also the concept of relevance, you can think of different characteristics. Now, assuming that these are different dimensions describing our documents, topics, and relevance interpretations, then we can say, well, if these are the different dimensions, then what we have done so far is that for some points in this huge n-dimensional space, we have some observations. So, for example, here we have clay, and here we have track, and here we have INEX, and here we have NTCIR. But now, what if someone comes and says, well, my collection is over here? We have no idea. We just, from this huge n-dimensional space, we just have observations for a few points, but for the whole space, we know very little. Now, we might want to start and say, well, but maybe for document length, we have already some knowledge. So, for example, we have short articles from track and clay, the news articles. Then in INEX, we have journal articles. We have patents, which might be even longer than journal articles. And then in INEX, now we have the book search, text searching in full books. So we have at least some observations for varying document length. Well, unfortunately, the results so far, they are incomparable because there are other collection parameters which are different between these test collections. And furthermore, the types of topics used for this collection, they are also different. And finally, also, there are other definitions of relevance. So the results actually are incomparable. We have results for different values of length, but all the other controlled parameters, they vary, and so it's really not possible to draw any conclusions. Just 2 months ago, there was an article in Communications of the ACM, which I would like to cite, which points out the limitations of empirical approaches, or purely empirical approaches. And the article starts with the observation that there are two kinds of empirical approaches in science, and currently dominating is the verificationism. This is the optimistic approach, assuming that induction is possible, assuming that if we only have enough observations, we may be able to perform some kind of induction for other points we have not observed so far. But the popular counterexample is Russell's inductive turkey, where the turkey living in the yard who's fed every day by the farmer, so the turkey infers that the farmer will do so till the end of all days. The other kind of approach is falsificationism. That's the pessimistic approach, which was proposed by Karl Popper. And this is a rather negative approach. Well, he says, well, we only live with conjectures, and they are all preliminary until they are falsified. So this is a rather negative approach, saying, well, with experiments you can only falsify any hypothesis, but you never can confirm any hypothesis. But we can see that both types of approaches do not really bring our field forward, at least if they are